So in this video, we're going to look at how can we use Excel to perform exponential smoothing model. Before we answer the question, before we start to show the exponential smoothing using Excel, we need to understand when we can use exponential smoothing models. So in order to use exponential smoothing model, it's similar as moving average. So the data has to be stationary. So in the practice question number 1, when we are developing our line chart, we were able to notice that for this gasoline price data, it is the shifted horizontal pattern. That means the data has no seasonality, no trend, so the data is stationary. So therefore, we can use exponential smoothing. Okay, so for this exercise, we're going to use exponential smoothing model, and then we will use the smoothing constant equal to 0.2. And then after that, we will calculate MAE, MSE, and MAPE. And at the end, we're going to compare the model from question 3 and 4 with the question number 5 to see which model actually give us a better forecasting outcomes. Okay, so we're using this data. So as you can see in my data set, if this is the first video you watch in this computer skill, and you should watch the previous video before you watch this one, because especially the video about how to calculate MAE, MSE, and MAPE. I already show how to set up this Excel sheet. So if you don't know how to set up, you should watch those 2 videos before you watch this one. And also in the previous 2 videos, we are able to calculating MAE, MSE, MAPE for the naive and moving average with 3-period model. So in this exercise, we're looking at exponential smoothing. And then our alpha value equal to 0.2. Okay, so first, in order to do this exercise, we need to have the data analysis included in this Excel. So it's under the data tab. So if you never use the data analysis, it will not show up here. You actually have to add in this data analysis. So at the very beginning of this computer skill, I had a video talking about how you add in the data analysis into your Excel. So once you add in once, you no longer need to add in more again. Okay, so under the data analysis, we actually have a function called the exponential smoothing. So let's find that. So it's alphabetic ordered. So you will be noticed that here they go, exponential smoothing. And then so after you choose the exponential smoothing, and you can click OK. So for the input range, and you will click this little arrow, and then you can click from B1 to B23. Okay, so from B1 to B23. And then the reason I do this way is because that I do usually like to include in my labels. So therefore, I'm including B1. If you did like what I did, so make sure you're going to check this box called labels. However, if you select data from B2 to B23, please do not select this box. So you select this box unless you include the data in your initial data selection. Okay, so the next called the damping factor. So the damping factor is another name for the smoothing factor. So as we mentioned in this exercise, so the smoothing constant or smoothing factor is 0.2. So I will just put in 0.2 into my cell. So next is the output range. So where should I put my output range? Some students might ask. Remember, for the moving average, it's a very tricky. Some students might put the wrong output range here. Similarly here, it's very important that you put the right place for your damping factor, because later you actually need to using that to calculate your accuracy metrics values, right? So where should we put our output range? So for the output range, you do not need to calculate where you put it. You are actually just need to select. So the output range, feel free to select the same row as your first observation of your actual values. Okay, so the first row here in column C, that's where I want to place my first forecast result. Actually, the first one here will be actually blank, so don't worry about it. So I select C2. After I do that, I also want to check chart output, because I do want to want to see how my forecasting look like. And so I'll check the output chart. Now I can click OK. Yes, that's okay. Some data may be hidden from the chart. Okay, great. As you can see that, so this is my exponential smoothing data. Okay, So it's look very different, right? As you can see, this is my forecasting output. And now what I will do is I will calculate in MAE and the MSE and the MAPE. And so you can see on the right hand side, everything already set up well. Like I said, if you do not know how to set this part out, you should watch how to calculate the MAE, MSE, and MAPE. Here, I just need to calculate in the value for this set. Okay, in the MAE cell, I will type equal average. And then I will select all the value under the absolute arrow column. And then close the parentheses. That's give me the MAE value. And for the MSE, I will type average. And I will select all the calculation under the square arrow column. And then close the parentheses and push enter. Lastly, for the MAPE, similarly. And then I will select everything under the absolute percent arrow. And then close the parentheses and push enter. Okay, great. Now I'm able to get in the MAE, MSE, MAPE for the smoothing model, right? Exponential smoothing model, 3.38, 16.33, 14.35. Great. So now if you compare the model, so you will notice that for the exponential smoothing model with the smoothing constant 0.2, we actually end up slightly doing worse than the MAE model when we are looking at the MAE value. However, if we look at MSE value, the exponential smoothing model is the best. If we look at MAPE, and then so that is the one slightly worse than the RMA model. Okay. So which model is the best? Again, I feel MA and also exponential smoothing, they are both very good here. But definitely you can play around this smoothing constant, 0.2, right? Maybe you change to 0.3, your model gets even better. So you can play around. Like I mentioned in the lecture, so for the smoothing constant, it's really you need to try a few times to identify the best one. So in this case, I just want to demonstrate how to do the exponential smoothing. Therefore, I just pick 0.2.